Okay, hey there, Math 9. So I'm going to do the second installment of the video series I've been up to right now, which would be Chapter 2, Lesson 2. So I'm going to get going with that. And we should be ready to go. Okay, so pop on over to our and the lesson that we did, Math 9, is Rational Numbers, Lesson 2. So let me just get into the right mode. And here we go. Alrighty. Okay. So when we're talking about rational numbers, one of the most important things that we want to do is learn how to use them in a way where we can estimate. Now look, I love to watch the show Storage Wars. When they go into a locker, if you've ever watched Storage Wars, that's a show where people bid on lockers, like storage lockers, and then they figure out what the value of things inside are. Now, when you look at rational numbers, okay, numbers that can be expressed cleanly as a fraction, for example, in Storage Wars, when these guys are looking at values, when they're looking at rational numbers, the ones that they like nice even ones. Like they look down and they say, well, that's worth $100 and that's worth $150 or that's $75. One thing you don't hear them saying is that's worth $75.25, and that's worth probably about 13 cents each. When you go to use numbers, rational numbers that are decimals and they're odd numbers like 13s and 17s and things like that, you quickly lose the ability to add. So this lesson is all going to be about rounding and estimating using rounding, just like those folks in Storage Wars would do. Okay? So let's get rocking and rolling. So you get a problem like this. I'm going to zoom in on this. And you see a number like 149.8 divided by 0.98. Okay, if you've ever done long division, that could be a lot of fun. Easier thing to do in this case is you have to put the decimal some point with inside that number. So where exactly should it go? Should it be between the 5 and the 2? Should it be between that 5 and that 7? Well, there's a real easy way to find out. Take 150 and divide it by 1. Because when you look at how this rounds up, that's really close to 150. And 0.98 is practically all the way to 1. Okay, so 150 divided by 1 is, make that even, 150.0. Okay, so the closest thing to 150 would be to put the decimal there. Okay, bingo, I got it. This next one, easy peasy. 2.7 is awfully close to 3 as a whole number. And 100.9, well, you're going to have to forgive me, but I'm going to round down to 100. And I'm going to say, well, that's basically like 300. Well, in the number 300, I just did a little erase-a-rooney here to create a little room. The number 300, 300.00. So we should have 3 digits, and then the decimal should pop in there. Done. Next one, 40.6 multiplied by 9.61. Well, why don't we just treat this as if it's 40 times 10, which is equal to 400.00. See, that gives me a really quick idea of where the decimal goes after, say, 3 digits. Okay, so the number that you see here is what a calculator would crank out. But as far as figuring where the decimal goes, well, it should probably go after 3 digits. First, second, and third. So there you have it. Next question. Well, looking at this, I could say, well, this is probably like 320, if I decided to round that way, divided by 100. Well, that would be, if you ever divide by 100, because there are two zeros in 100, here's a little trick. You can jump back by 2 zeros. So the answer would be 3.20. Now that's a little bit more exact than we would have seen before. Let's throw the decimal in there. Okay, what do we got next? Is 349 times 9 greater than or equal to 349? Okay, so here's the thing. If I could only get 9/10 of 349, did I get all of 349? Let's do an analogy. 350 points on a test. And you don't get all of them. Now 100% is like 1.0. So if I got 100% on a 350 mark, let's say law school test, I got all 350 points and I could feel good about that. But if I get 0.9 of them, I didn't get them all. So I'm not thinking really that I got all of these 349 points. I'm just treating it like 350 because that's a pretty number. But if I got 0.9, for those of you who remember back to Math 8, 90% is a loss of 10%. So I'm sort of thinking there is no way I got all of that 349, right? Maybe I got 342, somewhere in that range. Just, estimating, right? Take a few points off. You did not get all of them. No, you're not going to get all 349 points, okay? Now, here's another question. Good question. I'm going to choose a different color. I'm getting tired of purple. If you had, let's go with brown, if you had 48 divided by 16 giving you 3, 16 times 3, if you put 16 in 3 groups, you get 48. But if you only put 15 in a group, would you get a greater answer than 3? Well, here's a way of thinking about it. 16 into 3 groups perfectly makes 48. That's what this is saying. However, if I sort of think about 15 times 3, I get 45. And an easy way to remember that is there's 3 15-minute periods in an hour. 3 15-minute periods in 45 minutes, I meant to say. So, that being said, you haven't got all the way to 48, have you? You didn't get that far. So, if you take 48 and you think about it and you divide it by 15, the number that you're going to get is, if you do the hard math, you could say, well, yeah, I'd get 3 groups, but then I'd have leftovers. Because you've got leftovers, you have more than 3. You have greater than 3. So the answer is actually bigger. So that kind of makes sense, right? You can, sure, 15 can go into 48 3 times, but then there's more left over. Okay, so you have a larger answer. And the answer, we say, right, in as far as division goes, we'd say it has a larger quotient. Interesting to think about, isn't it? Okay, so item 4 on our list, it says estimate then calculate. I can do that. So a couple of students in the class said, well, what do you mean estimate then calculate? And I said, okay, since this is all about rounding, let's round and see what we get. You can do this with the calculator if you want and find out accurately, like exactly what it is. But let's just say this is 3. Let's just round that up. And plus minus. Okay, so if you're adding negativity, that's like adding debt. You're heading on the number line. If you're adding negativity and negativity is on this side and positivity is on this side, if you're adding negativity, you're going that way, which is really subtracting. So with my students, what I say is a plus minus condition, minus wins. Okay? What it really means is go left. So this is like 3, and if we just use whole numbers, it's like 3 minus 4. So we say, okay, well that's -1. When you do the decimal equivalents, you'll find, yeah, that it's -1 and a little bit. Okay, if this was Storage Wars, I would say, okay, I lost $1. Okay, I don't need to worry about the 10 cents right now. And that's good enough. In this case, I just look at the value and I'm like, that's -6. And then I see the sneaky little, let's grab this. I see the sneaky little minus minus right here. And I know darn good and well that if you subtract a negative, that's like adding. Subtracting debt, well, if you owed me $100 and I said, hey, I'm going to subtract your debt, that would be awesome because you get to keep the $100. You don't lose money. Think about that. That's like adding money. So a minus minus becomes a plus. And 6.83, let's round up to the nearest whole number. +1. Now look, you don't have to write +1. Most of us just understand that that's the number 1. Okay? But since there was a -1 up here, I thought I'd make the distinction. Alrighty. Let's push this up. So instead of adding and subtracting, what happens if we went to multiply? Okay, there's a couple ways to do this. So brown is out. We're going to blue. Push that over. There you go. So when you look at this, 0.45 is awfully close to one of my favorite decimals, one of my favorite fractions. I would treat this puppy as 0.5. And okay, some people would argue, well, it's not that hard to take a half of -1.2, but what if we just take a half of -1? That's not that bad. That's like a -1/2. The answer, if you crank it out on a calculator, is really close to -0.5 or -0.50. Okay, which is also a -0.5. A little further, you get a division circumstance right here. Okay, so division. That means divide. Half of what's wrong with these problems is you just have to know what it is they're saying to you. As I've taught this to my students in the past, they look at this and they're like, what are we supposed to do? And the number one mistake I see is they try to literally do the division like they see it, and out pops a calculator. If you pull out a calculator, you're doing the wrong thing when you're estimating. This is like -2 divided by a -1/4. Okay, so why did I do that? Here's the reason I did that. 0.25. You take a look at it. Most of us know when we grab a quarter out of our pocket, it is a quarter. Now, if you need to look at that with a little bit more information, what decimal bin is the 5 in? Well, this is ones, this is tenths, and this is hundredths. 25 pennies out of 100 pennies. Okay, divide it down, and you get a quarter. Okay, well, most of us know, right? Oh yeah, 25 cents, that's a quarter. I like it when I get something which fractionally I can write as a half, or I can write as a quarter, or anything like that, because I know the rule. I'm just going to change the color of my pen. Let's go with the good old irritating red. When you divide by a quarter, the rule is that you flip and multiply. Change it to multiply. Say done. I gotta go back and pick a new color. Back to purple. So -2, what gets flipped? Now this is where you gotta remember. You flip the numerator and the denominator after the division sign. So this is like multiplying by -4 over 1. Now, a couple of kids said, well, what am I supposed to do? I said, well, here you go. Any whole number, or I should say any integer, can always be expressed over 1. We can always put a value over top of 1, which means we can put it into at least one group, which is what that's saying. Well, take a look at it. What's -2 times -4? It's 8. Now, 8 over 1, 8 in one group. You have 8 kids, they're in one group. Well, that's 8. It's interesting because some of my students still ask me about the multiply and flip technique. Here's the deal. Let's pretend that you have 2 blocks, and you're supposed to divide that into quarters. And this generally works. Most of my kids see this right away. So if you're going to divide it into quarters, let's not even look at the negatives. Okay. All right. I have to divide it into quarters. How many times can I do that? Each of these blocks has to get quartered. That would be kind of like doing this, wouldn't it? I've got to divide this into 1, 2. Okay, so there's 1, 2, 3, 4. 1, 2, 3, 4. Okay, so if each one of these is a quarter, how many of those did you see? Well, if you're counting them up like I am, there are 8 of these things hanging out. So it's kind of interesting. It's the idea that if you take 2 things and then divide them up into quarters, there are 8 quarters. Okay, think about that. There's 8 quarters in $2. Similar idea pops out right there. Okay. So what they're looking at when you've got a fraction, and this is just a little bit of rehash from previous grades, but it's okay. When you look at a fraction, they're more or less parts of whole. So 4 out of 8 is like a half, and a half is like 0.5. Okay, just so the long division on that, if you take 2 and divide it into 1.0, you guys remember this, 2 goes into 1 no times, and you get the 1, bring down the 0. How many times does 2 go into 10? 5. Let me just scroll up here, give myself a little more room. Okay, so there's the answer if you have a half, for example, but more or less we all know this. So when you compare fractions, and I always tell my students, hey, how are we supposed to compare things? Like, let's say I cut a pizza into a third and you cut it into quarters, and we're supposed to share evenly. It would never happen. We would have to say, well, at the bare minimum there, cowboy, we'd have to make it out of 12. Because at least 3s and 4s, the first multiple they have in common is 12. So we'd start cutting our pizzas until they were all out of 12s, and we'd have equal-sized chunks. So when we look at something like 3/8 and 2/6, how the heck am I supposed to say how they compare? One way is to put them on a calculator and look at which decimal's bigger. Okay, that's fair. You could do that. Another way is just to adjust the fractions. So 8 and 6, the lowest common denominator, when you go through the times tables, and I'll erase this, when you look at 8 and you look at 6, 8 times 1 is 8, 16, 24, 6, 12, 18, 24. Well, look at that. That's the first thing that they both had in common as far as multiplying goes. So, that being said, take me a second to erase this. I'll erase the rest in a minute. When you look at that, how do we get 8 to 24? We multiply by 3. What you do to the bottom, you have to do to the top. 3 times 3 gives 9. Okay. 6 to go to 24, multiply it by 4. 8 times 4, or sorry, I gave it away, didn't I? 2 times 4 equals 8. Now, look. 3/8 is 9 out of 24. Okay, if you want to get it back, you could always divide it by 3, and you go right back to 3/8. So those fractions are equivalent. 9/24, 9 parts out of 24. I'd rather have 9 out of 24 than 8 out of 24. I'm a lot closer to 24, aren't I? So when we compare the fractions like that, since they came from these guys, since 9 out of 24 came from 3/8, it's the same fraction, just inflated, we know that 9 out of 24 is bigger, and 8 out of 24, which came from 2/6, is smaller. So you can compare fractions, but you better get them to be equivalent. They have to have the common denominator. And the biggest mistake that I see is when students fail to adjust the top and the bottom by the same amount. What's neat about that is you're basically inflating by a common fraction. This is how scale models work. It's the original dimensions, but just inflated. It's still the right size, but just larger or smaller. All right, so you come down here, and what you get are, let's see if I can call back my eraser here and clean up a little bit more of my mess. Best I can. Oh, it's not going to do it for me. That's fine. When we look at, ooh, come here, you. Go to purple. When you go to express a fraction versus its decimal value, this is 3 parts of 4. Well, if you look at that, you think about 3/4. Money helps you figure out pretty quick that that's 0.75, right? But if you wanted a decimal value, you could take 3 on your calculator and divide it by 4, right? That would give you 0.75. But most of us can do this from our understanding of sort of common, I guess I'd say, North American currency. Well, currency, I'll just use North American currency since I'm Canadian. When you look at this and you say, okay, what have we got? You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and 4 are shaded, 4/10. Or 0.4. So if you take 10 and go into 4.00, bring down the 0, line up the dots, and 10 goes into 40 4 times. Okay, so if you want to do the calculator thing, you can do it using long division. And this last one, quickly, 1, 2, 3, 4, 5, 6. So what we've got is out of 12. And we've got 3 shaded out of 12. Now that's very interesting, because if you reduce this, and as soon as you see that the numerator and denominator have a common multiple, for example 3, then you say, okay, I've got 1/4. Folks, this is why 3 months out of 12 in the financial sector is referred to as a quarter. Now, I don't know the number of times I've had students tell me that 4 months out of 12 is a quarter. And you say, no, actually, that's a third of a year. I think it's probably just the idea where there's a 4 and the student sort of confuses it. Not a big deal. It's okay. It's been done by many a student. Okay, so your final lesson comparison here is what's bigger, 3/4 or 7/10? So I did this lesson with my students, and they sort of looked at it for a second. I said, okay, guys, stop. Think about it. What is this as a decimal? Because that's useful. 0.75. And the kids, if you get 7 out of 10 on a test, a way of thinking about that, what's that like out of 100? Think about it. Oh, that's like 70 out of 100, or 0.70. And it's useful. I mean, decimals have their place. 75 is bigger than 70. All right, so here's the old hungry alligator analogy, where the small one is envious of the large one and tries to eat it. I always thought that was funny, because as a kid I thought, there's no way that'll work out. The large one will turn around and eat the small one. It's just an analogy. It's just something you go with it, as my math teachers used to say. In this case, you get to your final total here, and you say, okay, I've got 3/8, 2/7, and 1/3. You're like, oh, how am I going to compare this? Okay, you could get them all over a common denominator. You might have to do a lot of thinking as what the first multiple of 8, 7, and 3 are. I think probably an easy way to do this, take 3/8, and in this case, I'm totally fine with a calculator. That's 0.375. And a third, that should be a common one. You really just want to memorize that. 1 divided by 3 is 0.33. Okay, so you take 2/7. So you think about 2/7 and you're like, 2/7. It is okay to reach for the calculator. Now, you shouldn't really have to reach for a calculator, because long division isn't really that bad. 7 going into 2.00. All right, so let's crank this up and say, okay, I'll just do this long division because I don't have a calculator function here, and it's good role modeling. Okay, so I would say, well, 7 doesn't go into 2. I'm bringing down the 0. I jumped ahead. 7 goes into 20. Let's think about that. 7 into 20. Twice. Now I'm going to be pressed for space. Equals, we'll just kind of finish it over here, equals 6. That's the leftover. Bring down the 0. How many times does 7 go into 60? Let's see, 7 times 8. 56. Now, I don't even need to finish this, because as soon as I see this, I say, let's see if I can get the draw tool back. There we go. It's really being a stinker. It's not letting me erase. So let's just rewrite this just quick. You've got 0.375, and you've got 0.33, and looking at this, you've got 0.28 something. Okay. 3/8 came from that. A third is there, so I'll just circle these. Come here, you. There we go. 3/8, 1/3, and 2/7 goes with this. I know who's bigger now. 3/8. Let's see if I can find a little bit of room. I think I can. Change color. Let's hit done. There you. There we go. All right, we'll go with red. 3/8 is the big one because it was the biggest decimal. And 1/3 was next. And 2/7 was smaller than that. So if we go from largest to smallest, right, kind of go in what we call descending order, There you go. And I think decimals are fine for this. They help you to approximate. So why not go with them? Why not use them? I mean, they have their place too. So we started out the first part of the lesson by estimating. And by the time we got to the end of the lesson, we were not just using estimation, but we used a little bit about what we know about fractions and decimals to see who's bigger than who. Okay, I'm going to call it at that. Um, Thanks for listening. Have a good math class, and hopefully I helped you out a little bit.